Yolo. Okay, we're going to kick off with our first speaker is Ben Hatchwell. And Ben was actually one of my PhD students working on guillemots on Scoma. And so I'll talk a little bit about my guillemot research later on. But what often, those of you who might have done a PhD, often when you get to the end of that PhD, you kind of go, oh, I could have done that better. Because it's a learning process, it's part of your education. And I was extremely fortunate in having Ben turn up, wanting to do a PhD, and me thinking, well, he could do it better. And so basically, Ben repeated my PhD and did do it better. And that was really the incentive and the motivation to carry on with the long-term study, because Ben demonstrated there were several things that I fantasized about being able to do with guillemots that he proved that it was possible to do. So I thought it would be useful to start off today with Ben giving us a kind of an overview of what seabirds are all about. Why are seabirds special? So I'm just going to leave it to you, Ben, to tell us why they're special.
Okay, thank you very much, Tim. How do I find my...
I'll do that, you can start.
Okay. Yes, so as Tim said, my role here today is really to talk in very general terms about seabirds. I want to talk a little bit about the characteristics of their biology that make them a real challenge for population biologists, for conservation managers, and so on. And then to look briefly at some of the threats, both globally and also in a Welsh context, and the importance and the difficulties of monitoring their populations. So if we imagine a spectrum of life history strategies, seabirds are extremely challenging. The majority of birds would live at this end of this spectrum, where they live fast, die young, might only live for a year or two, have large broods. Seabirds, on the other hand, tend to have extreme longevity. They may live for many decades. They have deferred reproduction. They may not breed until they're teenagers, and they may breed only every 2 years. So in many respects, they're equivalent to kind of very long-lived animals like elephants and ourselves. I discovered yesterday that I was looking for an example of a long-lived human, and I punched in Old Welshman into Google Images, and a lot of Tom Jones popped up when you do that. Okay, so this simple nature of their life history makes studying them very challenging. The other aspect of their biology that represents challenges is the fact that we can observe them relatively easily when they're at their breeding colonies, but of course that only represents a relatively small proportion of their year. They spend most of their time out at sea, and when they're out at sea, they're feeding on a food resource which we find very difficult to sample, to understand the abundance of, availability, and so on. And certainly it's very difficult to monitor changes in this marine environment. So seabirds are fundamentally challenging. Let's move now on to the threats that they face. Now the first threat I want to talk about is fishing. Now, in a few instances, fishing has turned out to be rather good for seabirds. So the rapid expansion of fulmars in the last century into the UK and elsewhere in northwest Europe was probably on the back of discards from trawlers fishing in the northeast Atlantic. But by and large, that is an exception. By and large, fishing has many detrimental effects for seabirds. So sometimes that effect is direct, as in long lining, catching albatrosses in the Pacific and other places. But more often, the effect is indirect through the competition that trawling poses for the prey of seabirds. And so this figure shows the sand eel fishery. This is the annual catch in the North Sea from the 1950s through to the 2000s. And you can see this massive growth in this industrial fishery. This grey block here is Danish trawlers. And obviously this kind of catch is unsustainable, and it obviously has knock-on consequences with starvation of seabirds seabird nestling chicks in the colonies bordering the North Sea. The second threat, which we're all too familiar with in South Wales and the Western Approaches, is oil pollution. In the course of my association with Skoma, since I started my PhD, there have been 4 major oil spills affecting Skoma guillemots. Predators are also important, particularly on oceanic islands. These perhaps a lesser threat for many of the Welsh islands, but introduced predators in particular on oceanic islands have really caused major damage to many species, especially smaller species living on remote islands that have rats or cats introduced by visiting boats. And perhaps one of the greatest, but perhaps least well-known effect is that of climate change. And around the Welsh coast, of course, the climate change in the marine environment is normally measured using the North Atlantic Oscillation. This is simply a measure of how wet, how windy, how cold the seas are. And the only point you need to extract from this figure is to show that in recent years, in the last 2 to 3 decades, the North Atlantic Oscillation has been predominantly red. That means the seas are getting warmer, the winter's getting wetter and windier. One of the symptoms of climate change is, of course, as we've experienced over this last winter, an increase in the frequency of extreme events. And one of the current crises afflicting seabirds in this area is the consequence of the adverse weather events we've had over the last few months. So this figure shows the ring recoveries of puffins over the last, during the winter, over the last, since the 1950s. And there was a big major wreck of seabirds back in 1983, and the same thing is going on at the moment. And Tim's going to talk more about this a little bit later on. Okay, so that's on a global perspective. What about threats to Welsh seabirds? Well, if you go along and you count seabirds on Skoma, then you might be fooled into thinking everything's fine, they're going on very nicely, and there are no particular threats that we should be worried about. But if we look a bit wider from Skoma, if we look first of all to the south, we see that there are really major causes for concern. So back in the 1930s and 40s, there was a large population of guillemots on the Iberian Peninsula, so in Portugal and in Libya. Since then, they've become extinct in this part of the world. The same thing is happening, has happened on the western coast of France. So the southern distribution of guillemots appears to be marching steadily northwards. That's going on to the south. And if this is a function of climate change, then we can expect the same. We might expect this to start affecting colonies in south and west of Britain. If we look to the north, as I've already said, there have been major problems in colonies largely probably driven by changes in food supply, that have caused the reduction in population of many species of seabirds. So here's one example. This is the population of shags in the Hebrides, 2 islands there, from the mid-1980s through to the present day. Here we have data for kittiwakes showing exactly the same pattern for the same period from the 1980s up to the present day, but 5 different colonies, all of which, with one exception here, are showing a steady decline in numbers. And these are really dramatic declines as well, down to just 10 to 20% in some cases. And if we've been working on guillemots in the mid-80s to mid-90s, we might have thought everything was doing fine, because at most of these Scottish colonies, populations were doing quite well. But since the late 90s and 2000, again, we see dramatic population declines at many colonies around Scotland. Now, how do we deal with this problem? First of all, obviously, it's important to understand those population changes. So going out and counting, censusing seabird colonies is a really important function. Otherwise, we wouldn't know about those effects I've just been showing. The trouble is, monitoring tells you what's happening to the population, but tells you nothing about the causes of the changes. And what we really want to do, of course, is to understand what drives population changes. So how do we go about that? Well, if we want to understand population change, we effectively have to look at 4 different parameters. We have to understand the productivity, that's the number of offspring being produced, number of births. We need to know how many of those offspring are recruiting into the breeding population, so surviving from leaving the nest and becoming breeders themselves. Once birds become breeders, we want to know what their survival rate is, their annual mortality, and we also need to know how many birds are moving around from one colony to the next, the immigration and emigration from given colonies. If we look at each of those in turn, productivity is, people who spend a lot of time watching cliffs or with their arms down burrows won't like me for saying this, but productivity is perhaps one of the easiest aspects of their biology to measure because you can observe it at their breeding colonies with relative ease. But understanding how many of the offspring produced at the colony actually become members of the breeding population is a much more important parameter to understand, and that is a real problem. So here are some data from guillemots, which Tim and I collected on Oscillation, and this shows the age at which birds which were ringed as chicks were first resighted. So no birds at all come back to Skoma as 1-year-olds. Some come back as 2-year-olds, a lot come back as 3-year-olds, but some birds are not resighted until they're 8, 9, or even 14 years old. So even though they do ever end up breeding on Skoma, they don't do so for a long, long time, or they don't appear on Skoma for a long, long time. This right-hand figure shows the age at which they first start breeding, and most birds don't start producing offspring until they're 6, 7, 8 years old. And again, there are some real outliers here. This 14-year-old, first time it bred. So you can't just go and observe a colony and get any taste, any flavour for the recruitment. You have to invest long-term to understand what's going on. What about adult mortality? Well, one strategy, of course, is to put lots of rings on birds and hope they'll be recovered when they eventually die. And that might give you some index of their survival rate. So, for example, this is these dots, contour plots for the recoveries of ringed guillemots from Skoma. The problem is, if one wants to understand what's happening on a year-by-year basis, you need much more detailed information. And again, we can do that using individually marked birds. So you can mark a cohort of birds and then go back and see how many of them survive a given interval later. Of course, there are various problems with that. The more time you spend watching, the more birds you'll see. If you only go visit a colony for a brief period, you don't see many ringed birds. The longer you stay, the more you'll see. And of course, you don't necessarily see every bird every year. So, for example, this black line here shows the proportion of ringed birds seen in the year following the year they were ringed. If you add in the year after that, then a number of birds that weren't seen in the first year are seen in the second year. So you have to constantly revise your estimates of survival. And then finally, there may be substantial immigration or emigration from your study colony. So since I've been working on involved in the Skoma guillemot study, we've had about almost 200 recoveries of or sightings of birds from other colonies. Many of those come from Saltee and Hebrides, but we've had birds from the Isle of Man and even from the Baltic turning up as breeders on Scone. Now once you've got all that kind of information, then you can put it together, build a population model, and ask, do I understand what's going on in this particular population? So you know what productivity is, survival, to different life stages and so on. And this figure shows the actual population size on Scone in closed circles, and this shows the predicted population size using the parameters we've measured. So that suggests with the long-term data that you can get a very good understanding of how populations are changing. And once you have that, of course, you can start asking what ecological factors affect each of these population parameters. Can we explain deviations from this general population trend by variation in climatic variables, North Atlantic Oscillation, pollution, fish abundance, or whatever? So, to summarise then, seabirds are really challenging for conservation biologists and for population ecologists because of their slow life histories and the fact that they spend so much time away from where we can observe them. They're exposed to multiple threats, mostly anthropogenic ones, some of which we know quite a lot about, others which are very much unknown. Counts provide crucial information on population trends, but to understand what processes underlie those population changes requires very intensive observations of marked individuals for very long periods of time. You can't be reactive in these monitoring or population studies. You have to be proactive. The systems have to be in place before wrecks occur, before oil pollution incidents occur. So maintenance of long-term studies, as I'm sure we'll hear multiple times today, is absolutely crucial for the long-term management of these populations. Thank you very much.
Okay, we've got time for one or two questions. Could you just explain a little bit about the gillowatts in particular, why you can't just go and count all those colorations easily each year, why you have to kind of rely on that recycling process?
Yeah, okay, so there are two things going on. First of all, birds turn up back at the colony at different times progressively through the year. So not all birds are there at the beginning of the year, they turn up through the year. And some young birds, those younger cohorts of birds I showed you in the earlier graph, may not turn up until 2 or 3 weeks before the end of the breeding season. They turn up at the colony briefly and they're gone again. Some birds will take years out, so they don't come back to the colony at all. Other birds turn up, but we just don't happen to see them because they live in difficult, around a corner on a rock that we can't see very easily, or on a different colony. So understanding or getting those sightings and putting them into a population model that really reflects what's actually happening to their survival is extremely challenging, and there's all sorts of complicated statistical ways of doing that that take account of the fact that you can't see everyone every year. But it does require, you can't just go along and do a quick assessment of how many rings are out there. You need to put in the hours, but also combine it with these statistical modelling.
Yeah.
Hi, have you been looking at what the birds are feeding on? Has that changed recently at all? And can we equate that to changes in climate or perhaps fisheries or anything like that?
Well, the diet of guillemots on Scone has actually remained remarkably even over since the 1980s at least, which is predominantly sprats with some soundings. Now, there are blips. There are some years when we see a very large proportion of relatively poor quality food like gaddies being brought in, presumably in the absence of sprats or lower abundance of sprats. But I think I'm right in saying that the rate at which chicks are provisioned and the diet they're provisioned with has not really changed substantially over the last 30 years. And that's reflected in the fact that productivity has also remained very high, unlike what we see in Scottish colonies. Yeah.
The graph for annual fisheries increased dramatically, but then it did seem to decrease in the last couple of years. Is that, it's likely to stay, is that due to measures to reduce fisheries? Is that good news?
It's good news, but it might. I suspect it might also be driven by the abundance of fish that are left. You know, if they've all been fished out, and I'm not. To be honest, I'm not sure. Tom Oakley will talk later about fisheries and fish availability. Would be in a better place to comment on that. But yeah, I don't know whether it's a short. They're fished out or...
There is a moratorium at the moment on saddle fishing in the North Sea, isn't there?
Can you say that a bit louder?
There is a moratorium at the moment on saddle
Oh, is it?
fishing in the
Okay.
North Sea.
Okay. So hopefully stocks should be recovering.
Yeah, so pretty much, I think we're basically told to stop fishing because we're fishing.
Okay.
Okay, thank you very much. We'll move on.